Welcome to our channel Circuits Analytica. In this video, we will discuss solution for this problem. So here, we are asked to find the value of Vg2, Vx and V2 if Vg1 is equal to 1 volt for the network shown. So this is the network which is given for analysis. Let us mark three nodes, node P, node Q and reference node R. To find the unknown term Vg2, we have to apply KVL for the first loop, which consists of 12 volt source, resistance with a voltage drop Vg2 and resistance with a voltage drop 8 volt. So loop current is assumed to be in the clockwise direction. So let us apply KVL to the loop. We will get this equation minus 8 plus 12 minus Vg2 is equal to 0. So we are moving in the clockwise direction. When we approach the term 8 volt, as we move from positive potential to negative potential, that term is taken as negative. When we consider 12 volt, we move from negative potential to positive potential in the clockwise direction. So 12 volt is taken as plus 12. And when we consider the term Vg2, moving in the clockwise direction as we go from positive potential to negative potential, Vg2 is considered as minus. So we have the equation minus 8 plus 12 minus Vg2 is equal to 0. That means Vg2 is equal to 4 volt. Now we are going to consider the second loop, which consists of voltage terms Vg2, 7, 9 and Vx. So here Vx is the unknown term. Direction of current flow is assumed to be clockwise. Now apply KVL for the second loop, which consists of Vg2, 7 volt, 9 volt and unknown term Vx. So first of all, we will consider Vg2. When we move in the clockwise direction, as we go from negative potential to positive potential, Vg2 should be taken as positive. Next, let us consider 7 volt term. In the clockwise direction, as we move from positive potential to negative potential, this 7 volt term is taken as negative, minus 7. So Vg2 minus 7. Considering the third term, 9 volt. In the clockwise direction, as we move from negative potential to positive potential, this term should be taken as positive. So the expression becomes Vg2 minus 7 plus 9. Now considering the fourth term, Vx, in the clockwise direction, as we move from positive potential to negative potential, Vx should be taken as negative. So now the equation becomes plus Vg2 minus 7 plus 9 minus Vx is equal to 0. And we know that Vg2 is equal to 4 volt. So we can write the expression as 4 minus 7 plus 9 minus Vx is equal to 0. So rearranging the terms, we will get Vx is equal to 6 volt. Now let us find the third unknown term V2. To find the third unknown term V2, we have to apply KVL to the third loop, which consists of Vx, V2, 3 volt source and voltage drop across resistance R1, VG1. So this is our loop. Loop current is assumed as clockwise. Now let us apply KVL to this loop. We will get Vx plus V2 plus 3 minus VG1 is equal to 0. So in the clockwise direction, when we consider Vx, as we move from negative potential to positive potential, the term Vx should be taken as positive. When we consider the voltage term V2, in the clockwise direction, as we move from negative potential to positive potential, V2 is also taken as positive. Considering the third voltage source, in the clockwise direction, as we move from negative potential to positive potential, the 3 volt source should be taken as positive plus 3. Considering the fourth term VG1, in the clockwise direction as we move from positive potential to negative potential, VG1 should be taken as negative minus VG1 is equal to 0. So Vx is equal to 6 volt. VG1 is given as 1 volt. We have to find the unknown term V2. So Vx plus V2 plus 3 minus VG1 is equal to 0. The equation becomes 6 plus V2 plus 3 minus 1 is equal to 0. So we will get V2 plus 8 is equal to 0 or V2 is equal to minus 8 volt. We have computed the values of all the unknown terms VG2, Vx and V2. VG2 is equal to 4 volt, Vx is equal to 6 volt and V2 is equal to minus 8 volt. Thanks for watching Circuits Analytica. Enjoy learning.